All right. I usually end up recording my other class, but they've been ahead of you all year long. But you guys are caught up, and you're doing this lesson ahead of them now.
I'm gonna search myself up on YouTube now and listen.
Yeah, you'll see. So make sure you have your name on this. We are block 3. 1-3. Okay. Pythagorean theorem. This is something that sticks in people's mind. Probably sticks in your parents' mind. If one of the things that they remember from high school math is probably this thing. It's that working with triangles up on the wall there. Right. We'll talk about exactly what it is. Not this class, but next class. So today's class is just learning how to use the calculator for this kind of stuff. How to do all the different calculations. So if you can do this class, the rest of this chapter is relatively easy. It's just like deciding when to do the calculations. Today we're going to learn the calculations. Next 3 classes, just when to do which calculation. That's it. All right? To do it, you'll notice on this page, lots of exponents. So we're working with this exponent 2 a lot, all right, in this unit, right? So the exponent 2, if I say 3 to the exponent 2, going back to September when we talked about it, what does that mean? What is that calculation? William?
It's pretty much a times, right? Isn't
It is a times, but what are you timesing?
3 times 3 times 2.
No, not 3 times 2.
You times it by, yeah.
You times itself 2 times over, right? So this means 3 times 3, okay? Now, the word times is the word product. So if a number is multiplied by itself twice, the shorthand of saying that is we are squaring. Okay, Max, write this down, bud. Right? So that you can say 3 with the exponent 2, but the shorthand way we say is 3 squared. We're squaring 3, okay? And it means 3 times 3, which is, it's called we call it a square. Sorry, I got ahead of myself. And this process is called squaring. That should be down here, right? All right, so we're just going to practice this. Okay? So if I write down 8 to the exponent 2, what I'm asking you to do is 8 times 8. You grab your calculator, that's 64.
Wait, what? Oh, yeah.
8 to the exponent 2. All right? So I want you to figure out these 2 numbers. So use your calculator, come up with those 2 numbers. Give you like 30 seconds. All right. So what do we have for 11 squared? William?
122.
Not 122.
Oh, 121.
121. 11 times 11. What do we have for 2.5 squared? Carter?
6.
Can you give me the decimals after that? No, it should be more than 6. Elise? 6.25. So in this chapter, we'll be working with decimal numbers, right? So it'll be important not just round to the whole number. These little decimal numbers will make a difference, right? So either keep 1 or 2 decimal places. Usually they'll tell you in the question how many decimal places to keep. Okay, so step number 1, how do you square a number? Step number 2 is what I want you to be able to do is square 2 numbers and add them. All right? Right there. So, for example, 3 to the exponent 2 is 3 times 3, which is 9. 5 to the exponent 2 is 5 times 5, which is 25. Then I want to be able to add these numbers. 9 plus 25 is 34. Okay? Practice that with the next 2 questions. So write this middle step down. Just don't do it all in your calculator. Square this number, write it down. Square this number, write it down. Put a plus sign between it and add it together. Tell me what number it equals for the next 2 things. All right, let's talk about this one. Can anybody help me with this? First line, what do we write underneath here? William?
16 plus 64.
16 plus 64. Then what do you get when you combine those 2 numbers together? 80. All right. Next one. A little bit harder with decimals. Not that much harder, just more decimal numbers. What do we get? William?
9.4.
9.4? That does not look right to me. I think you did that in your head without using your calculator.
3 times 3.
Yeah, but it's 3.2 times 3.2. So we grab our calculator. Kaya had it right. 3.2 times 3.2 is 10.84. What you did, I think, is in your head. You took 3 squared, which was 9. You did 2 squared, which is 4.
Yeah.
But that's not 3.2 squared. Okay? So be careful with that one. 2.8 squared. Kai, sounds like you did this the proper way. What? 7.84. Okay, you combine these two numbers together, Timothy?
18.08.
18.08. Now, depending on the calculator you have, you might be able to do squares a little bit easier. Square is a very common calculation you would do in math and in science class. So if your calculator has a square button on it, you may want to learn how to use it. For example, my calculator has something that looks like this, x2. That does a square for me. So I don't have to type in, for example, the next one is 9 times 9. I just go 9. It automatically gives me the exponent 2. Check for your calculator. Most scientific calculators have this. That gives me 81.
What is it, x2?
Yeah, mine says x2.
I have x3.
Yeah, so give that a try. x3, if you have x3, yours will say x2 again. That's 25. Hmm?
Mine just tells you the answer. So it does.
Yeah, it may not show it. My calculator shows the calculation, but you may have that on there, right? That one has an x2. All right.
Sorry, well, mine doesn't show the equation, but it shows the answer.
That's fine. That just depends on your calculator, right? All right. So give it a try on the next two questions. We're not adding this time. This time there is a difference here. We are subtracting here, right? So find the two squares and subtract them. Write down the calculation. All right. Who's got the first calculation or the middle calculation here figured out? What's the next step here? Who shares the number here?
64.
64. Oops. Minus what number?
9.
9. Subtract those two numbers. What do you get, Kai?
55.
Good. Elise, you want to share the next one?
I guess that.
Your numbers looked good. What do you have?
51.84.
51.84.
Subtract 7.84.
7.84. And what do you get? 43.996. Yeah?
45.45.
I think it's 45. Let me just double check. So your two numbers looked good there.
Yeah, it's 9, not 84.
84 minus 7.84. Oops. No, the first number is not right. Oh, sorry, Elise.
Yeah, it's 53. It's 53.29.
Oh, 53.2. Oh, maybe did I just write it down wrong?
What do you mean?
53.29 here. Okay. And we get 45.45. There we go. All right. So, one more calculator button I want you to work on is the square root button. Now, this one's kind of funny depending on how your calculator works. For me, I push the square root button, and my square root button or yours may look like this, then the number. Some of you guys may have to go backwards order. You type the number, then the square root. So I hit my square root button, then I type in square root of 49, I get my answer 7. So see if you can do that. Find your square root button. If you can't see it, call me over. Sometimes it's kind of hidden.
Do you just press it and then the number?
Then the number, or it might be the other way around. Now, some people's calculators work a lot nicer than other people. Some people have to hit a shift button to get to the square root, right? There's a couple people like that.
I didn't go off something.
So this is why it's really important to bring your calculator. Some people have to hit a shift button to get there. Some people have to change the order that put the button numbers in. So if you're borrowing one from me, which I'm willing to lend you one, as long as I have one. But I have lots of different kinds of brands of calculator, so each time you may get a different one, so it may work slightly different. So it's important to start bringing your own, right? You don't want to get the answer wrong just because you didn't know how to use the calculator, right? Okay, for this one, when you do the square root of 1600, what number did you guys come up with? 40, that's right. Square root of 56.25, what do we get? Sorry? 7.5, thank you. Okay, so now, the hardest these calculations are going to get is we're going to combine the left side of this page with the right side of this page. Okay? 2 steps. I want you to find the squares of each thing, add it together, then do the square root. For example, this would be 9 plus 25, which is equal to 34. So this is what I'm going to write down. Then I'm going to say the square root of 34, and then I get this number. Square root of 34, and grab my calculator.
Whoa. It's like, if I got it right, it's a bunch of numbers.
Yeah.
And all these things give your answer to 1 decimal place. If I want this answer as 1 decimal place, what would I write down? 5.8. So remember, if I say round 1 decimal place, you got to look at the number after to say how it rounds. 5 or bigger tells us to round up. So this is a 3 here. So this does not round up. So just 5.8. So I want you to do the 2 steps for the remaining 3 questions here. Find the squares, add them for the top one, then take the square root. And the 2 bottom ones, find the 2 squares, then do the difference and the square root. See what you come up with. Write down your little steps. This final answer. If you don't get the final answer, call me or Miss Kirby over. All right, so the final answer for this one should be 12.1. The final answer for this one should be 4.5. Final answer for this one should be 8.9. So if you don't get these numbers, call us over. We'll double check where you might be going wrong. So here's the thing. Next day, I'm giving you an equation, and things maybe start looking a little more complicated. But if you can do these calculations, you can do this entire chapter. You just gotta pick and choose when you're doing one versus the other. All right, so next day I'm gonna give you a formula. Sometimes people get intimidated by the formula. Don't. If you can do this, you can do this entire chapter. You just gotta know when to do everything. Yes? Just wait, we're not done our notes. We're gonna wait. Okay, on to the back page. 2 questions, or a couple of questions here. Okay, grab your calculator out. Go 12 to the exponent 2, or 12 squared. Tell me what number you get.
144.
144. 12 times 12, 144. Now, go the square root of 144. What do you get? 12. There's a connection here, isn't there? So the connection is the square root. In math, we say, instead of saying the opposite of squaring, we use this word inverse. It means the opposite, so you're undoing the square. So square root is the opposite of squaring. You're undoing the squaring when you take a square root. That's what it makes sense, right? So knowing that gives us a lot of power later on. All right, we'll go over here. Okay, so we worked a little bit with shapes, right? We did it as a warm-ups, yes?
Isn't root R-O-U-T-E?
No, R-O-T.
Oh, that's a different route. That's route.
Oh, T-E. Oh, yeah.
Nice try,
Yeah.
Tim.
Okay.
It's actually good connection.
Yeah. So, next question, it says, hey, we have a square that has a side length of 10. Okay? Now, a square, remember, all the sides are the same. We have 10 by 10 all the way around. And the question's asking us to find the area. We did this, right? How do we find the area squared? Do you guys remember this? No. All right? Anybody remember the formula for area of a square? No?
What about the area of a triangle, a rectangle?
No?
What's a rectangle?
right? It was like side times side, or length times length, or width times width. Right? How about I just write down side times side for now? Right? So in this particular case, that'd be 10 times 10. All right? Now, this is what we did earlier on. Can we write that in exponent form in a different way?
Yes.
How would it look like, Kai?
10.
10 with a little exponent 2. So instead of writing it that way, we can write it as this. But at the end of the day, these things mean the same thing. We calculate this. What number do we get? What is 10 squared, or 10 times 10? 100. Thank you. 100. Okay? So if we want to find the area of a square, you multiply the two sides together. They're the same. So you just take the square, you get 100. But what we can use this information. What if we're given the area, for example, in this question, we're given this area of this picture frame, and we want to find out how big is the side. Right? Remember, a square root is the opposite of squaring. So if we have this number, we want to go back to this number, what calculation do we need to do? If I give you 100, and I want you to figure out how big this side is, how would you do that? No? Is that right?
Divided by itself.
Well, you don't know what it is.
Squaring it.
Well, we square. So we had to go, let's say, this 100 square root. Yes. We had to oops, that's not right. We went this way. We squared, S-Q-A-R-E-D, squared to go that way. To go this way to figure out this number, we need to square root. Right? So here, if we're given the area of 174.2, how do we figure out how big the side is? Take the square root. Use your calculator.
13.1.
13.1. Now, oops, that's somebody's homework. Let's look at this one, because I have a feeling we have to do some rounding here.
13.2. 13.2.
174.2 square root. All right, so it's 13.1 like you said. We look at the number after. It's bigger than 5, so we round that up. Now, 13.2. Now, on this, did you understand that question? Did I go too fast? Now, they told us that the area of this picture frame was 174.2 centimeters squared. Remember, area was always whatever your unit was, square. Oh, that's not switching pens for me. What should the unit for the side be?
Centimeter.
Just centimeters. Nicely done. So 13.2 centimeters. Okay? So if you can follow the train of thought for all of this, the rest of the chapter, super easy. So we do a little bit of work with this in grade 9, and it shows up a lot in grade 10. When I taught grade 10, I taught the entire unit we're doing today in one class. And in 11, yeah. So it kind of goes away next year. We sort of just side mention it here and there, all right? But in grade 10, it shows back up again. So this will get stuck in your brains. Don't worry, you'll be fine. Yes, William?